Question number 2. The average kinetic energy E of a gas molecule is given by the equation E is equal to 3 by 2 kT, where T is an absolute Kelvin temperature. What are the SI base unit of K? So in this question, you have been given an equation. You need to find the SI base unit of K. For this, you need to make K as your subject. So you can see I have made K as the subject. K is equal to 2E by 3T. E is energy. Energy's SI base unit can be found using force into distance. Force is derived from mass into acceleration. Now energy can be derived from mass into acceleration into distance. The SI base unit of mass is kg, acceleration is meter per second, distance is meter. When you simplify, you get this answer kg meter square s to the power minus 2. Substitute this E in place of E here, and T is the Kelvin temperature, so that is Kelvin. 2 by 3 is a numerical value which do not have a unit, so we do not bother about this. When you simplify this, the term becomes kg meter square s to the power minus 2 k to the power minus 1. As you can check with these options, the answer is option D. Question 3. An analog emitter has a pointer which moves over a scale. Following prolonged use, the pointer does not return fully to zero when the current is turned off, and the meter has become less sensitive at high current than it at lower currents. Now the question says the pointer does not return to zero when the current is turned off. So basically what happened, when the current is zero, there should be a reading in the scale. So as you can see, when the current is zero, in option C and D, there is a reading. And in case of A and B, that's not happening. So option A and B are incorrect. Now the question says, which diagram best represents the calibration graph needed to obtain an accurate current reading? Now we know that option C or D is the answer. Now how can we make sure whether C or D is our answer? The next part of the question says the meter has become less sensitive at high currents than it has lower current. In this case, take equal interval of current. As you can see these red lines, I have taken equal interval of currents, and then correspondingly I have drawn the scale reading. As you can see in your option C, the scale readings intervals are reducing in C, while in option D, the readings are increasing. When the scale reading intervals are increasing at high currents, we can say it has higher sensitivity. Now you can see in option C, the intervals are reducing. So you can say at high current, it has low sensitivity. So the answer for question number 3 is option C. Question 4. The arrow represents the vector R. So this arrow is our vector R. Which diagram does not represent R as two perpendicular components? We have these 3 or 4 options. We need to check which resultant will not give this R vector. As you know, we can use a law of parallelogram. What is a law of parallelogram? If two similar vectors acting at a point simultaneously can be represented by two adjacent sides. That means from a point, if two of the adjacent sides are pointing in the opposite direction, then the parallelogram's diagonal would represent the resultant. That means when you complete it as a parallelogram, their diagonal will represent the resultant. As you can see, option A, the resultant is in the direction which gives you R. Option B, that also gives you R. When you see C, option C gives you R in an opposite direction. That means the direction of R is changed, which is incorrect. Also, if you can check with D, the R, your resultant R is correct here. So the answer which do not give you the resultant R is your option C.